Hi, physical geographers. Hope you're doing okay, keeping up, and learning a lot of interesting things in landforms. So, there are a few things that we're going to discuss today that really have to do with the mechanics of how landforms are formed and what occurs with them. So, we are going to get into detail on that today. So, internal processes, there are several different processes and several different theories, essentially. We have continental drift, theory of plate tectonics, so basically movement between plates, both diverging and converging, having to do with seafloor spreading and the formation of mountains. For instance, the Himalayas, which we see grow about 100 feet every 4 years. And plate boundaries, which we talked about. So we see accreted terrains. We also see hot spots and mantle plumes. So we do see some geologic activity occurring in that, which happens with volcanism and magma in lava flows. We have seen some action like that in Hawaii, and we've also seen some in the northwest United States. We see for hazardous gases, lava flows, pyroclastic flows, volcanic mud flows. So these are always monitoring, especially by the U.S. Geological Survey. Intrusive igneous features, we see plutons. For tectonisms, we see folding, essentially forming of mountains. Faults, we see opening up in terms of valleys, especially on strike slip, where we see movements going between plates diverging. Included are earthquakes, seismic waves, earthquake magnitude, shaking intensity, hazards, ground shaking, tsunamis, earthquake hazards. So we see quite a bit of this complexity of internal processes, examples in Northern Rockies. We're going to do a bunch of examples. Continental drift. So we can see essentially on the shape of the continents that we really have a very close formation when they were together in terms of Pangea, which is one massive large landmass. We see also evidence for tectonics of the plates through the essentially ridge system that is open on the seafloors, the seafloor spreading. Also see samples of that. See samples of subduction, basically opening up of the earth. Paleomagnetism, or past orientation of the Earth's magnetic field. I think we talked about that a little bit last chapter also, about the Earth's magnetic field changing. Ocean floor cores, you see that of the same material and similar patterns. Plate tectonics, basis of different plates moving to and fro each other. Just an example of that, of them getting organized. Let's look at that a little bit longer. So we can see all the different plates. 3 types of plate and boundaries. All right, you see transform, diverge, and convergence. Divergence going apart, convergence going together, transform usually going in different directions, or in one solid direction. Okay, divergent boundary, you can read up on that. Example of the mid-ocean ridge, continental rift valley, convergent boundaries coming together. See that with many of the mountains in the folds. Different types of convergent boundaries, oceanic, continental, and transform faults. We talked about as the third type of plate movement. 2 plates slip past each other laterally, which essentially causes a transform and usually causes a force to go in one direction. So we see different plates occurring over geological time, going back millions of years ago. There's an example of that with the plates moving to form other continents from Pangea. And we also see the Pacific Ring of Fire, which is a great example. It goes throughout the whole world, which suggests that essentially there are plates and there's also continuous land that is moved apart. As additions to plate tectonic theory, we have hotspots, essentially volcanoes, which we talked about. Accreted terrain, small to medium mass of lithosphere bounded on all sides by faults. See an example of that going up the west coast from The United States, also to Canada and Alaska, which is again in the United States. Volcanism connected with the origin and movement of molten rock. Here we see examples of volcanic activity. Magma chemistry, we talked about that earlier in terms of different types. Lava flows, also discussed magma. Shield volcanoes, different type of structures with magma where events occur. Interior, exterior compositions. Composite volcanoes essentially have different lava flows, crater and crater vents. Tend to erupt explosively, have different rock formations. Lava domes, cinder cones, volcanic hazards, ash, which we've seen if you've been near volcanoes. I know Mount St. Helens, the ash reached most of the United States. And then we have igneous features, igneous intrusions, bodies, batholith, large buried igneous body of unknown depth. Here we see features of volcanic neck of igneous features, dikes, veins, sills, laccoliths. Spend a little bit of time with that. Here we discuss some models of folding, anticlines, synclines, so upfolds and downfolds, respectively. Faulting. Major faults can serve as conduits for water and magma, so flow can happen through gravity. Normal faults, reverse faults, compression stresses, thrust faults or overthrust fault, and then strike slip faults. Well, get examples there. Fault scarps, we can have steep cliffs caused by faults. We can have tilted fault block mountains. It's mountains that are created at an angle. Block of crust uplifted between two parallel faults. So Horst, and then grab it and down throw a block between two parallel faults. And then linear fault troughs, which we see shifting happening along the fault line. So here we can see that right around that location. Okay, and then earthquakes, we have epicenter, essentially where it occurs. Magnitude on the logarithmic scale. Besides the Richter scale, there's also the modified Mercalli scale. The Richter scale is logarithmic. Here we talk about the Mercalli scale, 1 to 12 categories. Spend some time with that. Ground shaking, liquefaction, loosening saturated water due to earth movement, tsunamis. We saw Fujiyama in 2011. We also have earthquake warning systems. Shake alert from the USGS basically indicates quickly prior to major earthquakes and when earthquakes are also happening, and then seismic monitoring networks also. So we do see examples in the Northern Rockies of internal processes moving, vast amounts of sedimentary rock, igneous intrusions. See quite a bit. That concludes our Chapter 4.